In section 7.4, we're going to add and subtract radicals. So we're adding and subtracting different roots. Well, remember that when we're adding and subtracting, even if it's, let's say, two fractions, they have to be the same type of fractions. We need to get a common denominator. If we're adding variables, we can't add an x and a y unless they are the same type of variables. X's can only get added with x's and y's with y's. So just like those cases, it's going to be the same thing with roots. I can only add a square root of 2 to something else that's going to have a square root of 2 in it. That means that when you're adding and subtracting, you have to add things that are like terms. They have to be the same. In this case, just like variables, our roots have to be identical. They have to be matching up, and then we can just add normally. So for this little example I made up, we have 1 square root of 2 plus 2 square roots of 2. Well, it's just like saying a 1x plus a 2x would give us 3x. A 1 square root of 2 plus a 2 square roots of 2 gives us a 3 square roots of 2. You're just adding and subtracting normally. The like part stays the same. So let's take a look at this first one. We have, let's see, 2 square roots of x plus 3 square roots of x. They are like terms because they both have a square root of x. So we've got 2 of them plus 3 of them is a total of 5 of these square roots of x's. So that's our final answer, 5 square roots of x. And you could do this because they are like terms. Now let's look at B. We've got 5 square roots of 3 and minus 3 square roots of 3. They are like terms because they both have the square root of 3. So I have 5 of these square roots of 3 minus 3 of the square roots of 3, which means I'm only going to be left with, subtracting normally, 2 square roots of 3. Now let's look at C. C looks like we don't have like terms, but they actually are because they can be simplified. We do know that the square root of 25 is just the number 5. And we do know that the square root of 81 is just the number 9. And we are subtracting, so 5 minus the 9 is going to give us a negative 4. We can subtract at this point because they're like terms. They are just numbers. So I can do the 5 and the 9 here because they're like terms now. They're just numbers. You took care of the roots. Let's look at problem D. Now in problem D, again, we have 2 completely different roots. Let's see what we can do to maybe force them to be like terms. Because we can't do anything with them if they aren't like terms. So let's start out with that. Let's actually start out with the smallest root. That might be easier. So let's start out with the square root of 8. Well, luckily, with the square root of 8, there is only one way you can break down an 8, and that's as a 4 times 2. So let's see how that'll help us to see how we can force these to be like terms. Well, the square root of 4 will come out as a 2. Actually, the square root of 4 will come out as a 2 to get multiplied by the other 2 that was already there and will become a 4. But this other 2, you can't take the square root of that one, so it's stuck on the inside of the root. Okay, so that part is done now. So my hope is that these 2 pieces will end up being like terms, meaning that they'll both have square roots of 2. So my hope is that I can backtrack and rewrite this square root of 32 as also something that will give me a square root of 2, so that then they'll be like terms. So can I break down the 32 into 2 times something? Absolutely. The 32 is 16 times 2. So Taking the square root of the 16, it will come out as a 4 to multiply by the 4 that was already there, which will give you a 16. That 2, though, you cannot take the square root of, so it will stay inside. Now look, magically this did work out. We've got a 16 square roots of 2 minus a 4 square roots of 2, which is 12 square roots of 2. So that's my final answer, is 12 square roots of 2. Let's look at problem E. So on problem E, we have 5 square roots of 8 plus 3 square roots of 72 minus 3 square roots of 50. Let's see if, again, we've got 3 roots. If we can turn all 3 of them into like terms, that would be wonderful. So let's start with the square root of 8. That's probably our easiest one. Well, the square root of 8 can be rewritten as 4 times 2. Okay, well, let's see how that one's going to work out for us in our favor, hopefully. Well, let's see. We've got the square root of 4, which is going to come out as a 2, times your 5 you already have as 10, but you'll be stuck with that 2 inside of the square root that you can't do anything with. Now, the hope is, on this next piece, we have a plus 3, is that you can break down the 72 to be left with a 2 also. So, question, can you rewrite 72 as something that'll have a 2 left over? You actually can. It'll be 36 times 2. Well, the square root of 36 will come out as a 6 times your 3 you already have will give you a positive 18. But yes, you will have the square root of 2 left over. Now in the next one, we already had a minus 3 on the outside. The question is, what's going to happen with that square root of 50? And if you can break that down into something that's got a leftover 2 as well. And you can. 50 is 25 times 2. Well, the square root of 25 will come out as a 5 to get multiplied by the 3 that's already there, which will give me a negative 15. The 2, just like all the others, will be left over inside because you can't take the square root. But look, we now magically have 3 terms that are all like terms. Why are they all like terms? Well, they all 3 have a square root of 2. So they're matching like terms. So then we can just add them normally. Well, we have a 10 plus an 18, which is 28. Minus 15 will give you a 13 square roots of 2. And we're done.